Hello everyone, good day. Today I'm going to discuss the inclusion-exclusion principle. This inclusion-exclusion principle is very important in the area of combinatorics and probability because using this principle, you can uh, you can guarantee that there is no repetition of numbers that are being counted. So before I'm going to discuss the principle of inclusion and exclusion. Let me have first this review of the two types of sets. Okay. So first one we have joint sets. So when we say joint sets, these sets have elements in common. Example, I have set M and set N. So for set M, the elements are 5, 6, 7, and 8. And for set N, I have 4, 6, 7, and 9. So if you are going to look at it, both M and N have elements in common. These are 6 and 7. So therefore, this type of sets are joint sets. When we see these joint sets, these sets have no elements in common. They are mutually exclusive. Okay? So example, we have set C consists of elements C, A, and T. And for set D, we have elements D, O, G. If you are going to look at it, there are no elements in A that are also found in there are no elements in C, I mean, that can be found in set D. So, this is called a disjoint sets because they have no elements in common. Okay. So, the principle of inclusion and exclusion, this is a counting technique that computes the number of elements that satisfy at least one of several properties while guaranteeing that elements satisfying more than one property are not counted twice. And it is a counting technique which generalizes the familiar method of obtaining the number of elements in the union of two finite sets. And symbolically, it is denoted by the cardinality of the union of A and B is equal to the cardinality of A plus the cardinality of B minus the intersection of A and B. So for example, you have sets A and B, and if you are going to get the elements of A and B, example, for A I have 1, 2, 3, and for B I have 2, 3, 5. If I'm going to have the union of it, I will have 1, 2, 3, and for B also 2, 3, 5. So uh, there are elements that are common in both sets. The 3. So in order for 3 not to be counted again, so you have to get that intersection. So that is why you have there minus the intersection of A and B in order for a particular element not to be counted twice. Okay. So, according to the principle of inclusion and exclusion, if A and B are subsets of universal set S, then the difference of A and B, difference of B and A, and the intersection of A and B are these joint sets. Meaning to say, these three have no common elements in all of them. They have no common elements. Okay, so looking at the figure below, this is the illustration, the Venn diagram illustration of the principle of inclusion and exclusion. So, you have set A and set B. And in both sets, there are elements that overlaps, meaning to say, there are elements in both sets that are common to both of them. So, ditong region na makikita nyo, yung may darker blue na part, yun yung part na nag-overlap yung elements ng set. Ibig sabihin, sa dalawang sets, ito yung sa gitna, ito yung mga common sa kanilang dalawa. Okay? In order for these elements not to be counted again, so you have to get their difference. That's why you have A intersection of B. Okay? So, as seen from the figure, you have the difference of A and B, union with difference of B and A, union with intersection of A and B is the same as the union of A and B. So, let us have a proof on that. So, given if set A is equal to the elements A, B, C, D, and E, and for set B, we have the elements A, E, F, G. So let us find the difference between A and B and the difference between B and A. So, from previous topics that we have in operations of set, when we say difference of A and B, you have to look for the elements in A that cannot be found in B. Okay? Hahanapin mo yung elements ng A, na hindi mo makikita sa B. So, in this instance, for set A, we have B, C, and D. Yung elements na B, C, and D, wala yan siya sa elements ng set B. So, that's why the difference of A and B is equal to B, C, and D. Now, to get the elements of the difference of B and A, this time, hahanapin mo yung elements of B that cannot be found in A. So, looking at the elements of sets A and B, we can say that elements in B that cannot be found in A are F and G, because A and E can be found in A. So, we only have F and G. Let us also find the intersection of A and B. When we say intersection, it means to say these elements are the common elements of both sets, or these two sets are joint sets. Okay? So, again, looking at the elements of the sets. The common elements in both sets are E and A. Okay, so for the intersection of A and B, we have elements A and B. Okay. And getting the intersection of A and B, you are just going to combine all of the elements of A and B. And if there are elements that are repeated, you are only going to write the element once. Meaning to say, wag mo na uulitin pagsulat. For example, set A and set B both have element A. So, you only write element A once. Okay. So, A union of B is just equal to A, B, C, D, E, F, and G. Okay. So, we have observed that we just copied elements, or we just combined elements of A and B for their union. Okay. Using the Inclusion-Exclusion Principle, okay, so we have here, let us prove that the cardinality of the difference of A and B, union with the cardinality of the difference between B and A, union with the cardinality of the intersection of A and B is just equal to A union B. So, substituting the values we have solved previously for difference of A and B, we have B, C, D. For the difference between B and A, we have FG. And for the intersection of A and B, we have AE. So, getting the union of the three, we have A, B, C, D, E, F, G, which is just equal to the union of A and B, which is also equal to A, B, C, D, E, F, and G. So, this this has been proven. The inclusion-exclusion principle. Okay, example. In a discrete mathematics class, every student is a major in computer science or mathematics or both. And the number of students having computer science as a major, possibly along with mathematics, is 25. The number of students having mathematics as a major, possibly along with computer science, is 13. And the number of students majoring in both computer science and mathematics is 8. The question, how many students are there in this class? Okay. So, using the symbolic representation of inclusion-exclusion principle, we have the cardinality of A union of B is just equal to the cardinality of set A plus the cardinality of set B minus the cardinality of the intersection of A and B. Okay. So before we are going to solve that one, let us first have the Venn diagram illustration of this problem. So first, we have here two sets. The two sets are the first set A. These are the number of students having computer science as a major. So there are 25 students in it. Okay, set A. For set B, these are the number of students having mathematics as a major. So there are 13. Okay, for set B. But there are students that are majoring in both computer science and mathematics, and there are 8. So that is now the intersection between the two, meaning to say these students are taking both computer science and mathematics. So intersection of set A and B. So applying the inclusion-exclusion principle using its equation, so we have here A union of B is equal to the cardinality of A plus the cardinality of B minus the cardinality of the intersection of A and B. So for our set A, we have 25 students for which having computer science as a major. And for our set B, we have 13 students. These students having mathematics as a major minus the intersection of the two, meaning to say this intersection are those students who are taking or majoring both computer science and mathematics, and there are 8. So to get the answer, you have here 25 plus 13, that is equal to 38 minus 8, that is equal to 30. So therefore, there are 30 students in this class. Okay. Next example. How many positive integers not exceeding 1,000 are divisible by 7 or 11? Okay. If you're going to do it manually, you can. And you can use the Microsoft Excel. With Microsoft Excel, you are going to enumerate all of the numbers from 1 up to 1,000. And then, each number, divide that one by 7 or 11. And then get those numbers that have a result of whole number. So, bali, enumerate mo lahat yung 1 to 1,000 and then, and every number that you have enumerated, you have to divide it by 7 or 11. One column for 7 and one column for 11. Okay. And then, kukunin mo yung result ng division, kukunin mo yung number na whole number na na-generate niya na answer. And then, enumerate all of those answer na may whole number. Okay? Para ma-determine mo yung number ng how many positive integers na pwedeng ma-divide ng 7 and pwedeng ma-divide ng 11. And according to the computation, numbers that are divisible by 7 is equal to 142, and numbers from 1 to 1,000 that are divisible by 11 is 90. Okay. And then, there are 12 numbers that are common to both 7 or 11 na result. So, applying the inclusion-exclusion formula, so you have there 142 plus 90 minus 12, yung common sa kanilang dalawa. So, that is equal to 232 minus 12, that is equal to 220. Okay. Dito sa baba, sa Venn diagram, ito naman yung illustration ng set A tsaka set B mo. The overlapping region, yun yung mga numbers that are common to both A and B. So, ito yung intersection nila and there are 12. Okay. Last example. How many integers from 1 to 100 are multiples of 2 or 3? Okay. Ilan daw yung integer from 1 to 100 na multiples of 2 or 3? So, for multiples of 2, so you're just going to divide 100 divided by 2. Meron kang 50 na numbers that are multiples of 2. So, those are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, up to 100. And then, for multiples of 3, so you're just going to divide 100 by 3, and that is equal to 33. So, you can have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on and so forth up to 99. Applying the inclusion-exclusion formula, which is the cardinality of the union of A and B is just equal to the cardinality of A plus cardinality of B minus the cardinality of the intersection of A and B. So, for cardinality of A, we have 50. Cardinality of B, we have 33. Minus the intersection of two sets, that is 16. Ibig sabihin ng 16, there are 16 numbers that are common to both A and B. Okay, example, sa A, meron kang 30. And then sa B, meron ka ring 30. So, isa yun sa mga common sa dalawang sets. Isa yun sa mga numbers na common sa dalawang sets. Okay? So, 50 plus 33 minus 16, that is equal to 67. Okay? So, that's all for today. And this principle of exclusion and inclusion is just good for two sets only. Okay, I will have another presentation later applying the inclusion-exclusion principle with more than two sets. Good day, everyone. Thank you for listening.